Is my screen visible?
Yes.
Yes, sir.
Okay. So today we'll discuss small signal model of transistor.
Excuse me, sir.
Yes.
Sir, I'm Akash Acharya. I am seeing one problem regarding my attendance. That is, it is showing 6 days absent in my SAP portal, sir. But I was present in all the classes.
You are present, but while I'm taking attendance, if you left, then I'm not the God who will know you are present.
Sir, but you don't take the attendance always, na? Means sometime you take the screenshots.
I always take attendance. I have never. I think how many classes were attended?
Sir, it is showing me 6 classes, but it is
No,
means
no,
I
no,
was not absent on 6 classes, sir.
no. How I am taking attendance? You know,
Sir, you are taking the screenshots of the student present in the classes?
I am recording that.
Yes, sir. And
Okay, from that recording, I am seeing the and putting the attendance.
yes, sir. I know
During,
that, but
so during that time, if you left the meeting, then how I'll know?
no, sir. I don't leave the meeting before you say.
Every recording, everyday recording is with me.
Acha, okay, sir. Please, but
And also, I am observing while suppose after the class, I am saying, "Don't leave. I'll take the attendance." And the meantime, some of the students are left. Those who are in hurry. So I cannot do anything. Na?
okay, sir. But please, you check once, okay, sir.
Your roll number
2105857.
5857.
So in my case also same
Every
problem.
case it will come. The problem I already told you. While I'm taking attendance, if you left, then I can do anything. So that 2-3 class, it is not an issue because 75% attendance is there. But my point is that while taking attendance, you should not leave.
Sir, it is not for 2-3 classes. It is showing that I am absent for 6 classes, sir.
6 class means you may leave. Okay, I'll check.
Okay, sir.
Because every time when I'm taking attendance, some of you are leaving the meeting.
Okay, sir. Please check once.
Sir, I was absent.
Another thing is that see, it is very difficult for my part to check every day because every day when I'm putting attendance, next day it will be updated. Even after class during evening time or 7 p.m. around that attendance should be updated. So if you are seeing anything like suppose you are present and it is absent there, then you should inform me in the next class. If you say after 3 months and 10 absent, 12 absent, how can I check which class you are absent, which class you are present, like that? Okay.
Okay, sir. But from now onwards, I will tell. But please check it previous before classes.
Okay.
Yes, sir. In my term also there are 5 options, sir.
So
Same here, sir.
Yes, sir.
6 absent.
Problem, sir.
Yes, sir.
okay. So leave it that. So
Okay, sir.
today we'll discuss few classes are actually I have not put it, so that is blocked. So I'll put it later on. Okay.
So, and on AEC lab we have 0 attendance.
I am not taking a lab.
Okay, sir.
Okay. Few classes, 2-3 classes. I think I have missed the attendance. Means like suppose this class is at 5 p.m. and we are shifting to 3 p.m. So at 3 p.m. I cannot put the attendance. So after 5 p.m. I may forget. So 2-3 classes are there. So I'll update little bit later because I have to mail them, and when they will open, then only I can update. That may be also another case. We'll see. So today we'll discuss small signal BJT model and RC coupled amplifier. So in this model, in this module, these are the topics we'll cover: introduction, then what is small signal model, and inside that RE model is in your syllabus for CE configuration because common emitter configuration is mostly used configuration. And after that we'll see single stage CE RC coupled amplifier. This is an amplifier, and using the concept of this modeling, we'll put it here and we'll find the small signal model for this amplifier, RC coupled common emitter amplifier. Once you do that one, then you can able to find what is the gain, means voltage gain, current gain of amplifier, and what is the input impedance and what is the output impedance of the circuit. Then we'll discuss the frequency response of this amplifier. Frequency response means for different frequency, what is the behavior of the amplifier, means the gain is changing, how the gain is changing, and what is frequently we are able to hear the one term bandwidth. Okay, so in that concept we'll cover that bandwidth. And if you look at the transistor, like diode we have discussed, this main function of this transistor is amplifying. So amplifier is used to amplify the signal level, right? The amplitude of the signal is amplifying. Suppose I am giving one signal like this, then amplified signal is like this. So you can observe here the amplitude of the signal is increased. Earlier this is the amplitude, now amplitude is increased without changing the frequency. So you see the time period, it is same for input and output, because when you talk for each person the frequency is different. If frequency will change, will not get the exact signal. What I want to transmit, that signal is not received. Something different I'll receive, which we cannot identify, or you can say the intended signal cannot be received. So amplifier mainly amplifying the input signal or increase the strength of the input signal. But how these things are happening? Okay, because we know energy cannot be created nor be destroyed, it is only transformed from one form to other form. So we are giving input signal, means it is having less energy, and we are getting amplified output, means the output signal level is increased, means the energy is increased here. So this small increase or energy, smaller level of energy to higher level of energy, so extra energy whatever transformed due to this amplifier is come from where? It is coming from the DC source, because if you not give supply, then you will not get the amplification action, right? All of you have seen that audio amplifier through microphone, someone is talking, then even music system or in public gathering we are using these audio systems. So when we talk through the microphone, that signal is converted to electrical signal, and that is amplified through the loudspeaker. We are able to hear amplified version of the input signal. Now if the switch is off, okay, power button is off, can I get amplified output? No, because the device is off. So actually this signal amplification is done by transferring the power from the DC source to the AC signal. Okay. Now if you look at the amplifier, this can be analyzed in two steps. One step is DC analysis and other one is AC analysis. So DC analysis is also called as large signal analysis, and AC analysis is called as small signal analysis. Why? Because the strength of the DC voltage is more, or the change is more, and here for AC means we are giving small signal or very, you can say, less number of or less amount of voltage, like millivolt, microvolt, like that. But DC we are giving 5 volt, 10 volt, 12 volt, like that. So comparing to these, the analysis are named and whatever, if you remember the DC analysis we have done, like load line, Q point, where the Q point will be in the load line, the transistor must operate in active region, Q point at the middle of load line, how to find load line, how to find Q point. Okay, all these comes under the DC analysis. Okay, so DC analysis we have done to bias the transistor and stabilize the Q point. In that case also we have find out the stability factor, fixed bias. Okay, all these things we have done. Now a small signal is superimposed once the Q point is, if you remember, this is the transistor characteristic, common emitter. So this type of characteristic we are getting, and this is the load line, and this is the Q point. So this Q point must be fixed, right? We have discussed the biasing conditions and how to stabilize this Q point. Once you fix this Q point by putting some voltage and resistance by appropriate calculation, then we have to put the AC signal. So once I give the AC signal here, then output I'll get the amplified version of the AC signal. So that means this is my DC, okay, and AC is superimposed on DC. Once DC condition is fixed, then AC signal is upon the DC level, so that AC and DC both will be amplified, and at the output again we'll separate AC and DC, and we can receive or we can get the AC signal, amplified AC signal. So the small signal or AC signal is superimposed into the circuit, and there is a very small compared to DC bias voltage. So compared to DC bias voltage, this AC is very small, so that's why it is called as small signal analysis. What's that? So when the signal variation with respect to Q point is small, then BJT input and output relationship is linear in nature, and equivalent circuit of BJT can be represented using linear elements such as resistor and dependent source. Okay, what is this point? If you consider this Q point at the middle and small variation across this Q point, then we can take this is the transistor as nonlinear device, and you can see here this portion is linear, and when the signal strength is less compared to Q point, we can take or use the nonlinear device to model in terms of linear device, so that the analysis will be easier. Okay, so resistor, current source, voltage source we can take. Like in diode, we have converted nonlinear device to simplified model, approximate model, and ideal model. Here also we can model this transistor as a combination of linear elements, so that it will behave as linear combination, but the operation or the result is same when we replace this transistor in the form of this model. So small signal model of BJT is required to analyze the amplifier to find voltage gain, current gain, input and output impedance of the amplifier. Without this model, it is very difficult to find all these parameters, because each time if the circuit complexity increases, we cannot apply KCL, KVL, the same whatever we have discussed in diode model, the same problem will arise here. But if you simplify, in place of transistor, if you put some linear component and we can easily simplify the circuit, then it is easy to find this gain, voltage gain, current gain, input impedance and output impedance. These are the four major parameters of amplifier. So the definition is written here. Small signal modeling is a common analysis technique in electronics engineering, which is used to approximate the behavior of electronic circuits containing nonlinear device with linear equations. So the behavior of the component is nonlinear, but we can approximate with respect to the linear equations so that we can replace these things with linear components and we can model it so that the mathematical calculation will be easy. These are the mathematical calculation which we need to do that will be easier. So what is a model? Already we discussed. Model is a combination of circuit elements properly chosen that approximate the actual behavior of semiconductor device under the specific operating conditions. Okay. Basically, there are two type of model is here. One is RE model and another one is hybrid pi model. But in your syllabus, only RE model is included because it is a little bit easy compared to hybrid model. So this RE model employs the diode and controlled current source to duplicate the behavior of transistor in the region of interest. That means when we replace the transistor as a model, then we use the diode as one of the component inside that, as well as the current source. Okay. If you take these two components and the concept of that is used here to model the transistor, so that if you replace the transistor with this model, then it will behave same as the transistor when it is connected in the circuit. Hybrid model, actually it is not included, but you should know hybrid means the term hybrid comes because the equation what I have told here, linear equations, that is the combination of current and voltage. Due to this hybrid combination of current and voltage, the parameters are extracted and that are modeled here. Towards the end, I'll show a little bit about this. Okay, now this is the basic amplifier configuration. What amplifier I explained here, or we'll see the RC coupled amplifier, that is this one. So if you observe this circuit, this is an amplifier. What is there till now? What do we know? This is one transistor. Okay, this is NPN or PNP transistor. Tell me, which type of transistor is this one?
NPN.
NPN. And this circuit also we have seen, but some extra component is added here. So you see this part. Instead of this two resistor, we have earlier seen only one resistor was there. That is fixed bias circuit. In place of this fixed bias or single resistor, two resistors are connected here. And according to voltage division rule, if you take the resistance like this, two resistor here, like last class I have told you during CMOS, if I'm giving 10 volt here, and this is R1, and this is R2, and I'm taking the output voltage from here to here, then what I'll get? R2 divided by R1 plus R2 into 10. This is the voltage I'll get. So this voltage is divisible or divided into this resistance. So this is called as voltage division rule. So that type of connection is here, and whatever voltage I'm giving here, that is due to this voltage division. So this type of circuit is called as voltage divider circuit. Okay. So transistor, this R1 and R2, and this is collector terminal, so this is RC, and this is emitter terminal, so this is RE. Okay. And if you observe here, input side one capacitor is connected, output side one capacitor is connected. These are called as blocking capacitor. Okay, these are called as blocking capacitor or coupling capacitor. Why the name is given like that? Try to understand here. Once I'll bias the transistor, Q point is fixed at the middle of the load line. Now after that, once I fix the DC bias condition, then I am applying AC here. This is my AC. Okay, this is the AC. Now if inside the DC, AC, whatever I am giving inside that, if some DC is present, then that will be also given to the circuit, and the Q point will be added by this DC, and they may shift upward or downward. So what I need to do I should block whatever DC is present in my input AC. So how I'll block the DC? You know, already we have discussed during the filter circuit, capacitor is blocking DC and passing AC. So this is my input. When I pass this one with a capacitor, so DC will be blocked here and AC will be given to the circuit. So that's why this is called as blocking capacitor. So it will restrict the DC present in a AC to moving into the circuit. Similarly, once it is amplified, okay, DC and AC is given. Already DC is given by biasing the circuit. 12 volt DC is present, so IB is there, capital IB. After that, AC I have added. Now at the output, AC and DC both are coming. So here I'll get AC plus DC. Now at the output, I have given input as AC. I want output as also AC. I'm talking, right? So my voice is AC. So at the receiver, that means at your end, you also expect my voice, which is AC. So, but during this amplification, AC and DC both are amplified. So we have to block that DC. So here, one capacitor is connected, which will block this DC. Only AC will be passed to output. Right. So here also it is blocking the DC. So these two are called as blocking capacitor. Also, these are called as coupling capacitor because if I take another amplifier here through this resistor and capacitor, this is coupling to the second stage or connecting to the second stage. That's why this is also called as coupling capacitor. Okay. And this C3 is called as bypass capacitor. Okay. C3 is called as bypass capacitor because this capacitor, when AC is given, then for AC this capacitor will be short circuit and current, whatever current is going here, it will see two paths. Suppose this is short. Okay, this capacitor is short circuit and current is flowing through terminal VE. Now it has two paths. One is this path, other one is this path. Which path the current will flow? If capacitor is shorted, two path is there, one path resistance is there, one path that is shorted. So which path the current will flow?
Shorted one.
Shorted one. So current will flow through capacitor, it will not flow through resistor. Okay. So the AC current from emitter to ground, it will flow. So by removing RE, that means it is bypassing the current which is flowing through RE, because if RE through RE current will flow, the gain will reduce. We will not discuss that one. Only you remember that this RE will reduce the gain and this stability of this thing will improve by taking this bypass capacitor. Okay. So when AC is given, though it will provide the short path or shorted low resistance path to flow the current. So this is called as bypass capacitor because it is bypassing the current from emitter to ground. Okay. So these are the major parameter: transistor, then this is voltage divider resistance, these two are coupling capacitor, and this is bypass capacitor. This is given as AC, and here I'll get the output AC. So this is the general configuration of basic amplifier. Okay. Now what I'll do here in this circuit, if I want to find out voltage gain or current gain, input impedance, how you represent input impedance? Zi. Okay, Z is the impedance, so Zi means input impedance, output impedance is Z0 or Z0. So if I find want to find what is the gain of the amplifier, what is the input impedance of the amplifier, what is the output impedance, it is very difficult to find because I don't know how many resistance are there. You see here, this side, these two resistance, and if I look at here, then it is quite difficult to find out what is the impedance of this circuit, this side, input side or output side. But if I model this transistor such that I'll simplify the circuit and I can easily calculate the resistance. Okay, we'll see that one a little bit later. So we'll model this transistor in terms of these linear components like diode. Now, to understand this modeling, we need to understand the two-port network. Okay, what is two-port network? It is like a black box. You see, this is a system and it is having two sides. This is input side and this is output side, right? So two sides are there, that's why it is called as two port, or two pair of terminals are there, that's why it is called as two port. Any system can be taken as two port network where input and output is there. Now if I look at from input side, the parameters of two port network, listen here. So the parameters are, if I look at from input side, how much impedance I'll see from the system, that is your ZI, input impedance of the system. Similarly, if I look at from input side, what is the voltage I'll see, that is called as input voltage, and how much current is going into the circuit, that is your II or input current. Similarly, if I look at from output side, how much impedance I'll see, that is Z0 or output impedance, this one. Look at from output side. Output side voltage is V0 and output current is I0. It is always going from output to inside, means outside to inside I have to look at, and current is also into the system. Everything is into the system. Okay. So making more simplified here. So ZI is the combination of resistance. So here it is written as Ri and here it is written as R0, and current and voltage II, I0, Vi and V0. Okay, more simplified of two-port network. So anything we can frame like two-port network. Now see here, I want to convert this one to a two-port network and I want to make a model. Okay, so you see this is the amplifier. So there are certain steps you have to follow to find the AC modeling of this amplifier. So what is the first step? Set all DC sources to 0, right? So this is my DC source VCC. So VCC means DC source, so I'll ground it. So you see here the DC source is grounded. So first step is first ground the DC source. Okay, so you see this VCC is connected to R1 as well as RC. So grounded means R1 is grounded as well as RC is grounded. Second step is set all capacitor to short circuit. Okay, so we have one capacitor here, second capacitor here, third capacitor. So all these capacitors are sorted here. You see this one, this one, this one. Three capacitors are sorted. Next, remove the bypass elements. So I already told this is the bypass capacitor. So when you sort this capacitor, then we have to remove the bypass element. So this is removed here. Then redraw the AC equivalent model. So redraw the equivalent model means till now we have not discussed the model of this transistor. So apart from that, you have to redraw and we will replace this transistor here. Whatever model I'll do, I'll replace here. Okay. Now we'll see how we'll model the transistor. So just a minute. Now see how I'll model the transistor. So this is emitter. Yes. Collector. Okay. Now, if I want to model, I can take this one. This is base, this is collector, and this is emitter. Now you observe what is this type of transistor, NPN. This is N, this is P, and this is N. And you see here, this is like a PN junction. So if PN junction is there, then I can put a diode here like this. This is P, which is connected to base, and emitter is connected to or N side is here base. Now how current is flowing? Current is outgoing here. So here IB is flowing, here IC is flowing. So collector to base, I'll take a current source IC, which is equals to beta IB. Okay. Have you understood this one? How I have replaced this one? This transistor, base and emitter, PN junction. So I have replaced with a diode, and from collector, current is flowing. So that current is, for common emitter, IC equals to beta IB, ignoring the leakage current. So I have represented as a current source, which is IC equals to beta IB. Here, you need to understand the difference between DC and AC. So when I am taking DC, I will represent as capital I, capital B, capital I, capital C, capital I, capital E. So all are capital. But if I take AC, then it will be capital with small letter. Capital I, small b, capital I, small c, capital I, small e. Right? So this is RMS value or AC value. So whatever we have discussed in DC load line, Q point, we have represented as IB. Even characteristic, we have discussed IB, IC, and IE, that is in capital letter. But here we'll discuss as small, means capital I and small b. Okay. And we have seen the resistance of diode. So here we can represent this diode resistance as RE. Okay. And some calculation, mathematical calculations are there. We are ignoring that. If you do that one, then we'll get this RE equals to 26 millivolt by the diode current. So here diode current, because it is connected to emitter terminal and we are taking emitter current, so I am writing here IE. Okay. So instead of diode, we can replace this resistance and redraw the thing. So here this is the RE. Okay. And what current is flowing here? IE. From here, what current is flowing? That is IB. Okay. And what is the voltage between these two? That is base emitter voltage. Up to this clear? How I'll write AC, how I'll write DC?
Yes.
Now I'll simplify a little bit more, and for that I need to calculate some more parameter. So what is IE? IC plus IB, right? And IC equals to beta IB plus IB, that is IE. So IC equals to, I can write beta plus 1 into IB. Yes or no? Sorry, IE. IE equals to beta plus 1 into IB, which is nearly equals to beta IB. Yes or no? Emitter current equals to base current plus collector current. Collector current is beta IB. So if I take common, then I'll get this type of thing. Now, what is VBE? Between base and emitter voltage. Okay, so this voltage is equals to beta IB, or I can write like this: VB equals to IE into RE. What is IE? Beta IB into RE. So this is my input voltage. Now what is impedance? Input impedance. Input impedance is VI by II. So VI is equals to VBE and II equals to IB. So I'll just replace here beta IB into RE divided by IB. IB cancel. I'll get beta RE. Yes or no?
Yes.
Now I have got what is my impedance, input impedance. That means if I look at from input side, what I'll see. So I'm keeping this is base, this is emitter, just remodeling that one. This is base, this is emitter, and if I look at from this side, I'll see the resistance as beta RE. What I have just now found. Okay. Output side, this is emitter. Output side, what I have got. See, from here to here, I have found out what is ZI, then I have replaced. So between base and emitter, I have redrawn. Then collector to emitter. So collector to emitter means this current is flowing. So what I'll do, I'll take current source like this. This is your collector. This is your beta IB. Okay. Now see, see the initial transistor, then how we remodel it, how we have found out the input impedance and replace here between base and emitter as beta RE, which is a resistance, and output side collector to emitter, that is beta IB. So here this is the dependent current source. So the square type of if you remember in the square standard, dependent current source, independent current source, dependent voltage source, independent voltage source, how we are representing. So this IC is depend on IB, so this is a dependent current source, so beta IB I am writing, and across that we will find one resistance which is generally represented as small r0 or output resistance. Okay, so this is called as RE model of CE. Okay, transistor. So wherever I'll find the transistor in common emitter configuration, I'll replace this with this circuit. So total transistor, initially this is my transistor. Okay, this is emitter, this is base, this is collector, that will be replaced by this. Now you will say, sir, what is the advantage here? We can directly find the ZI as beta RE. If I look at from this side, then I can find the output impedance, which is R0. Then what is the voltage here? This is VBE. And what is the voltage here? This is VCE. Then what is the current, input current, that is IB, and what is the current from that side, that is IC. So I can easily visualize all these parameters or not. Input voltage, output voltage, input current, output current, and input impedance, output impedance. So this thing is like a two-port network. So I have shown you a two-port network. This is like a two-port network. So here to here, Zi, this is Z0, then input current, output current, then output voltage, input voltage, plus or minus, plus or minus. So that is quite simple if you take this model. Similarly, the common base model is also there. It is a little bit easier than this one, but in your syllabus, common emitter is given because you are familiar with this one and it is more used. So we have done this one. You can also go for common base configuration. So next class we'll go for this replacement. Okay, we'll replace this transistor. Okay, whatever the model we have received, we'll replace here, and we try to find out the impedance of this total amplifier, because if I take only this transistor, then I'll find beta Re. Okay, but this transistor is inside this amplifier. So if I take this total amplifier as an two-port network, then what is my input impedance, what is my output impedance, what is the gain of this amplifier, voltage gain, current gain. We know for common emitter configuration, it will give both current gain and voltage gain. We'll see how much voltage gain we're getting, how much current gain we're getting. Okay, we'll understand that one. And after that, we'll go for other topic. So we'll stop it here today. If you have any doubt, you just ask me. Whatever we have discussed. This is the model. You see, these are the transistors. Then we have P model here. Then this is the third step, and fourth step we're getting this one. So here this will be dependent current source. It is written as like circle. Circle means independent, but it is dependent. So you have to take the square. So this is the RE model for common emitter transistor configuration. Next class we'll again put it in the amplifier, then solve it.
Sir, in SAP in AC section it is showing 2 days absent, but I was present all days.
That is very good. You should present. You must present and maintain present in the class.
Sir, but it was showing 2 days absent, sir.
No problem. Today, I think at 5 p.m. the Moodle link will be opened for student link view. All of you see that one. What I have. Have you got any mail?
No, sir.
No. Maybe you'll get. I think some of the students have got the mail. You check it after 5 p.m. the Moodle will be open or not. I have got a mail that.
to check तो नहीं दिखा था. थोड़ी देर पहले के लिए तो नहीं दिखा था.
No. I have got mail from the exam cell that at 5 p.m. the link will be open. So you check it after that. And the problem with your solution or answer sheets are everything is same. Whatever someone is writing, the same thing is writing everyone. So mark is also like that. So whatever problems is there, most of the problems I have observed. The first thing is that let me tell you here so that repeatedly will not ask the same thing. One question is there. Okay, so one question was there. Center tap transformer rectifier is given. and its input voltage is written as 50 sine omega t or 200 pi t, something like that it is written. So I have already told you, if the signal value is given in the form of V equals to Vm sine omega t, then this is your Vm. Okay, so Vm equals to 50 volt is already given, and for that you have to find out Im, that is Vm by Rf plus RL. Okay, for center tap. Then after that you have to proceed. But many of the students, many सब ऐसे ही किए हैं. Okay, everyone has written Vm equals to 50 by root 2. From where they have got, I don't know, but everyone has written. So that indicates what you have done. So if this value is wrong, then Im is wrong, I average is wrong, IDC is wrong, everything is wrong. Okay, so you need to see why you have done like that. So that is the first problem what I have observed. Second one is bridge rectifier question was given, like 1200 load resistance and RF is 100. Okay, so if you observe the bridge rectifier, 4 diodes are there at a time, 2 diodes are on. So Im equals to Vm by RL plus 2 RF. Okay, so 1200 plus 100, that is 1300. But most of everyone has done like 1200 plus 50. Okay, so if this is wrong means Im is wrong, IDC, IRMS, everything is wrong. Majorly I have observed this one, and clamper also few of have done wrong, like the VC calculation is wrong, and equivalent circuit and dynamic resistance and static resistance have came. So when this type of question will come, you have to draw the write the definition of equivalent circuit. We have seen 3 type of equivalent circuit: approximate model, equivalent model, simplified model, and ideal model. So you have to write what is equivalent circuit definition, and you have to give one example. Many of you have just written definition and nothing like that, example and all. And static and dynamic resistance also, some of you have written the definition as well as the formula, like P by I or dV by di, but many of you have written only the definition. Okay, and whenever the comparison or difference will be asked, depend upon the mark you have to give. Suppose 2 mark question is there, means minimum you have to write 4 differences. Okay, many of you have written 1, 2, 3 like that. So depend on that, marks are given. So these are the major things what I observe. Still, if you find any anywhere mark is less or like that, then you can contact me. And wherever these problems are there, because due to this problem or the mistakes, I have deducted some mark. So according to the process, for process I am given some mark, and for wrong answer I have deducted some mark. So you should be looking at that. Okay, so check it whether after 5 p.m. because it is now 4. So